All right. So, like I mentioned, I want to get this to work properly for nested elements. And also, as we saw earlier, there's some bad things in this code. Here we have some weird duplication in the subscriptions function. And, oh yeah, up here in the drag move function, we have this weird nesting because we're storing drag state different areas. So, okay, this is kind of a bit of a jump in refactoring, but here is how I'm envisioning solving this problem. So we have our frame, and frame can either be an image or a split with an internal frame. With two internal frames, which themselves potentially could be splits as well. So whenever we're dragging something, we're either dragging an image, in which case we're panning things around, or we're dragging a divider, in which case we're moving the divider. So since this is a tree, we need to know how to, whenever we're dragging something, we need to know what we're dragging. And I think we can represent that as basically a path through the tree, which is going to be a list of integers. So if the root is a single image, the path to that would just be an empty list, because there's nothing we need to navigate through. But if the root thing is a horizontal frame, then we need to tell if it's going to the left or if it's going to the right. And then so that the top image in a horizontal frame we can represent as 1 in a list. Or if there was like a second frame, then the bottom element of the top subframe be addressed in this way. So I'd like to define a type called frame path, and it's a type alias, and it's just going to be a list of integers. And we can use a frame path to identify any specific component or any specific frame within the tree of frames. So if we have this frame path, we want to record the frame path in our drag state, and then we can use that when we apply our drag updates to dig down into the tree and find the right frame to update. So I think doing that is going to solve a couple problems. First, it'll make this actually work for nested frames, and second of all, it should remove a bunch of the duplication that we had here that was requiring us to deal independently with slider drags and image drags. Since we have a path now that can address anywhere in the tree, we can deal with those in a single field. So hopefully that sounds good to everyone. Let's do it. So rather than having separate drag state and slider states, just going to have a single drag state. This will be a record. Start position is going to equal a mouse position, and the path is going to be a frame path. So whenever we drag something, we have to tell it which frame is the subject of the drag. So given that, let's follow the compiler. So to start out with, subscriptions is wrong. So let's go fix up our subscriptions function. So here it is. Now, just based on drag state, get rid of all this extra junk we put in here earlier. So if we have a drag state, we will subscribe. If we don't, we won't. Seems simple enough. Now, our update function is the next problem. So let's go deal with that. So here, this doesn't exist anymore. Instead, we're saying just a drag state, and inside of this maybe is now a record that has the start position and the path in it. So we'll destructure both of those out of the maybe. And what do we want to do? We want to apply drag. We're going to generalize this apply drag function. Let's jump down to the method signature for that first. So here we have two different versions for our different things. The position version is more general, so we want to use that. And then also we're going to need a path on here. Not sure if there's a best place to put the path. Try putting it as a first parameter. Okay, so this is not correct implementation yet, but this is the signature that I think we want for apply drag. We'll take a frame path, the current or the change, the frame that we want to transform, and we'll give back a new frame. All right, so now back up here where we're applying that. First of all, we need the path, which we have. Then we need the change, which is this whole thing we built for dragging images, which has both an X and a Y. Then we have the frame that we want to update, or at least the root frame. So the way this works is we'll start at the root frame, check if the path matches at that level, and if it doesn't, we'll recurse down into the frame, kind of pulling items off of the path as we go down. So I think this is pretty much what we want. Except the the drag state needs to be updated to have the path is going to be the same, and the start position now is going to be our current position. So we need to update the drag state. And no command. Okay. And then all of this for dealing with the image state goes away. And then if there's no drag state, we just return current model with no commands. And then also our drag update function, we can condense this down, just changing the drag state to nothing. Okay. So I feel like that is pretty close for our update function. So let's see how this is going. This is in 135. Is that our apply drag function? It is. Great. Cool. So here we have a frame, we have a path, and we have the delta x and y that we want to apply. And we're basically condensing these two things. So let me pull this one up here. We have a single image. This is how we deal with it. We can kill this function. Then we have no y change, that's just change.y. Okay, let's go. Okay, so we're not using the path yet. So we'll have to come back and deal with that, but it looks like this is good enough to compile that function at least. Let's see what else is missing. Our update function says is this, but it It uses drag image state. Okay, so let's just search for drag image state. Oh yeah, so here in our init, it's now just called drag state, and there's only one of them. All right, and still complaining. So let's see where else we're referring to that. Okay. So drag image start and drag divider start. These both need to change. Drag state, drag state. So those are wrong because now these need to be record. The drag state is now a maybe a record. Takes a start position. But it also needs a path. So we're going to have to figure out how to fill those in. So let me put a to do there and a to do there. But hey, we at least have it compiling. We can drag an image around the top level. So now let's get to the point where things are not implemented yet. I'm going to go back to my initial model and put back a horizontal split. Okay, so let's try dragging the slider. Ooh, okay, it's close. It's actually backwards. And I think that because of this, let's see. Might be a little confusing, but I was thinking if you're dragging to the left, that should be a positive offset. And if you're dragging up, that should also be a positive offset. Yeah, okay. Let's keep that the same. Oh yeah, this should just be the opposite. Okay. So we can still drag our divider. Try dragging the images. Oh, okay. So that doesn't work. Always dragging the slider no matter what I click. So here's how I'm thinking this will work. First of all, we need to hook up the path to be the correct, or to be provided by the event, or by the mouse click events. So like when we click the top image, we need to store the correct path in the model, or excuse me, yeah, in the model, in the drag state. So in order for that to work, we're going to also have to change our messages. So these actually can be combined. We just have drag start, but we also need a frame path. So now, whenever we drag the start of something, we get a path, and we can stick that into the drag state. So that's the first part of what to do. We need to figure out how to hook this up and pass it in. Once we have it, then we're going to need to work on the apply function and have it actually do something with the path. Okay, so down on 198, this is now just drag start, but we need to give it the path. And the way that will work is we need to, as we go through and render, we're going to need to take a path parameter in this function. As we recurse down, we'll build up that path, and then we'll have it to use our events. And here's the other one. Also drag start path. Now, wherever we've called view frame, have to build up this path. So in the view canvas, the top level, calling view frame. So the path for the root frame is just the empty list. Then, whenever we render a horizontal split, we're going to render the top. And the path for this, we're just going to define that it'll be a 0 followed by the current path. The path for the bottom child will be a 1 added to the current path. Okay. So now, I don't know if you can see this easily, but when you look at the drag state, if I click the slider, the path is empty. And if I click the top thing, the path is 0. And if I click the bottom one, the path is 1. So I feel like that's what we want. It's correctly identifying the path of the thing that I am choosing to drag. So let's implement our apply drag function. So in the case of the horizontal split, you basically want to check the path. You want to do case path of, and if it's an empty array, that means that this splitter frame is the frame that we're dragging. We want to continue to rearrange things like we used to. Otherwise, if the first element is 0, then we actually want to pass the drag down to the top frame. So we're going to recreate our horizontal split, but change the top element to now apply the drag to that top element. So the path for this is going to be the remaining path, the 0 pulled off of it. The change is the change, and then the frame here is old version of top. And the bottom will just be bottom. And we're basically going to do the same thing if it starts with 0. Except we're going to apply the drag to the bottom. And I think that's still an incomplete pattern match. Yeah, so I'm just going to take this case, stick it down here, and use that as the default case. Alright, give it a try. So we can still drag this. Now, yeah, we can pan the tomatoes and pan the beetle. And I'm expecting now also, if we had nested vertical sliders, should also be able to drag the nested sliders. I'm going to give that a try. Let me go grab one more image, maybe the moon. Yeah, here we go. Download this. Go to Imager. Stick this up here. Oops. Go. Okay, so we've got our top. Let's change the bottom to be another horizontal split, where the top is now going to be a single image, well, the old one we had. And bottom will be a single image. check the size of this. And 60 by 720. And the top height is 100. Okay. So let's see. Yep, we can successfully resize that and pan that. Oh, we've got a problem. I cannot drag the tomato. Oh, I see. Dragging the child. Problem. Wait, what did we just see there? So I can successfully drag the top, the root node. I can drag at path 0, drag at path 1, and drag at path 0, 1. Ah, that's backwards. And dragging at path 1, 1. That's also, that works okay. I see. So if I'm dragging path 0, 1, that, I see, that's backwards. So we need to reverse this path when we send it, because if I'm dragging this tomatoes, that should be 1 for the bottom frame and then 0 for that. Okay, there we go. I can drag that, and I can drag moon, resize this one. Perfect. Okay. So this file's getting pretty big. But we have successfully been able to move images. Okay, so here, dragging works for all nested frames. Okay, that has been a lot of coding so far. Let me take a second to clear my head. So what have we done? We have the ability to drag. We have the ability to pan things around. Obviously, there could be some things added here, like being able to split vertically instead of just horizontally. And, well, mainly that. That's the main thing I can see. But I think doing that is less interesting than moving on to make an image picker that uses a JSON API. So, yeah, let's give that a try. I feel like I'm starting to really slow down after 2 hours of coding and talking at the same time. But let's see how this goes. So, the website we've been grabbing these images from, Pixabay, has a great API. Oh yeah, and I mentioned all their images are CC0, which is essentially just a formalization of public domain. So it's free for any use, including commercial use, and there's no attribution required. The way they work is when you sign up, they encourage you to upload your own images and contribute images, which is, I guess, how they built this community. But they also have a great API. So I'm going to just search for that. Pixabay.com API. And they have some really nice documentation in here. So we want to do an image search. And I've already logged in and signed up for an account, so they have an API key in here for me, which I guess I need to reset after this stream. But this is super easy. To do an image search, all we have to do is click this link and it pops up with the JSON. And then here's the query parameters where we could change this to whatever we want. So let's start this out. We basically want to hit this endpoint and show the results. Oh well, we'll have to hit the endpoint, parse all the JSON, and then we can show the results. So let's start out with putting, I guess just putting a button, and eventually we'll want a text box where you can type whatever query you want, but let's add a button for now, and when you click the button, we'll fire off an HTTP request to this endpoint, parse the JSON response, stick it in our model, and we'll be good to go. Maybe we should also start this as a new component as well. So let's build this out in a new file. This will be called image search.elm, module image search, and we will expose the view. And I guess for testing, let's stick program in here. Let's see, what am I doing wrong with this? So we'll go to image search.elm. Oh, we need to say main equals program. Have no view. View takes a model and returns HTML message. And let's just stick our button in here straight off. And we'll need our model type for this image search component. Start with just unit. It's compiling. We'll need a message type. I guess we can immediately add this. Do search or clicked search button. Yeah, I like do search better. And we'll add that to our button. HTML events.on click do the search. We'll need to import HTML events. Then we need initial model. And we need subscriptions. We won't have any, so I'll just do this shortcut with an anonymous function. And then we need our update function. case message of, and when we have do search, then we'll do something with that shortly. All right, so here is our search button. Got a little bigger. And we can click it. And let's also put debugging on here for the moment. Okay, so when we click it, we get a do search message. Great. So next up, we want to make our HTTP call. So we're finally going to get to use commands. So HTTP requests are tasks, which we can use task.perform to turn it into a command, and then that's how we'll get the data out. So let's take a quick look at the HTTP package. So we're going to use this get function. It'll take a decoder, which will be used to decode the JSON. Takes the URL, and it gives us back a task. So let's do this. I guess the first thing we need to do is define the data structure that will represent our JSON response. So let's define that here. We'll call it Pixabay search response. This will be a type alias. It's usually good to make these records. And let's see. What's in here? Got total hits and hits, which is a list of Pixabay images. So let's define that. So we'll have total hits is an int. Then hits is a list of Pixabay image. And there's also a total on there. I'm just going to leave that off for the moment. And we also need to define Pixabay image. And what's interesting in here? There's no name for any of these, is there? Nope. Okay, I guess we just want the preview URL and the web format URL. I'm just going to call it preview web format. Cool. So there we have our data types, and we're going to want to decode those. So let's, we need to make a decoder for these values. So we'll need to import json.decode and make a decoder for each one of these. Let's start with the top one. I'll call this decoder. It's a decoder of Pixabay search responses. And here's the typical pattern for writing decoders. We'll say object2 because there's two fields that we need. Then we're going to use this type alias as a constructor. And then we give it the two parameters and define how they come out of the JSON. So this first value, total hits, it's an integer and it's coming from the total hits field, the JSON. So we'll say json.decode at total hits is the field. And then we need to give it a decoder that can decode the type of value that it is, so an integer. And then the second thing we want is the list of Pixabay images. So that was at the hits field. Yep, hits. And this is going to be a list of Pixabay images, which will be decoded using the Pixabay image decoder, which we'll write in just a moment. So this should be our decoder, search response. Now let's write our decoder for image. The image. So this is also an object too, because it's got two fields. Using Pixabay image, and then JSON decode at. Take a look at this. So preview URL is the first field we want. That's going to be a string, so we use the string decoder. And then the second thing is web format. That one's just web format URL. And yeah, that should be our decoder for that. So let's hook this up to an HTTP request. So we're going to make, instead of command.none, we're going to make http.get, which we need to import. And then we give it the decoder that we want to use, which is the search response decoder. Then we give it the URL that we want to use, which is this URL. And I think that's all. Give to get. Then we have to turn it into, so we'll get back a task, and we need to turn the task into a command. We'll use task.perform. And we've got to give it two functions. One that's used to make a message for the failing case, and one that's used to make a message for the successful case. So let's call it search failed and search search failure and search success. So these will both be message types that we need to define. So search failure will receive an HTTP error, and search success will receive our search response if it's successfully decoded. Okay, so I still have some compile errors. We don't have the HTTP module, we need to install it. So this is in the EvanCZ ElmHTTP package. So we need to get that. Elm package install. Now, how are we doing? I need to import the task module. Whoops. Too big. The error message. It says that my case doesn't have a branch for all possibilities. Our update function doesn't handle the success and error case. So let's, for now, just do nothing and see if we get any output out. All right. And let's see, Mickey VIP in the chat is asking how you handle object N if you have more than 8 fields. So there's actually, what I would suggest is there's a package that one of my coworkers wrote called pipeline decode. So this is a great library to use. So it's very similar to what we did, but you just start with your record type here, and then you just go through and say required with your decoders. So it's very similar, but it lets you chain on as many as you want. So that's one easy way to do more than 8 fields in a record. You can also, I think it might talk about it in the code for JSON. But let's see, object 8. Yeah, the other thing you can do is you can actually look at the source code for these and see how object 8 is implemented, and you could extend it and write your own. Let's see. We go in here to JSON, decode, object 8. Oh, never mind. You used to be able to look at how this was implemented, but now it's done natively. So yeah, you can do some stuff using the and then chain decoders, but it's probably at this point easier to just use Elm pipeline decoder. Alright, so let's hit this button. Hey, we've got some stuff down here. Yes, and in fact we have a search success. So I am excited about that. So now let's update our model. So if we get a search success, I'll just call this data. Then let's stick the list of images into our model. So let's go up and define, oh, we don't have anything in our model. Results is that our initial model will have results being an empty list. And then when we get search success, say model results equals data dot hits, I think we called it. And I guess then we should show those. So below our search button, we will show HTML dot, let's just make a UL. And then in here we'll do list.map view image of our model dot results. And we'll define our view image to take a Pixabay image and return HTML. And this will be HTML.image, HTML attributes source will be the image.preview URL. And let's also put a width and height on here. HTML dot attributes dot style, max width 100 pixels, max height 100 pixels. Okay, see how this worked. Import HTML attributes. I did forget a comma. Hey, there we go. Got a bunch of nice flowers. So we're able to search I guess I should commit there. And then I guess we've got to do a couple things. We'd want to add a text box where we can change the search text. But that's pretty straightforward. You can see how to do that in other tutorials that are available online. I think what I'd like to do is make these clickable and integrate it with our main app so that we can select image. So let me commit and then we can do that. Created basic image search. So how's the best way to structure this? So basically we have a bunch of messages here that are internal messages, and now we want to produce a public message that anyone containing us can use. So I guess one nice way to do this is that we can have our view take, let's see, we could have the view take a function that can transform this message. Let's see, I haven't worked through doing that in a while. Why don't we start with just making the message available publicly, and then we can look at closing that down later. So we want to define a message called image selected, and this will take a string, which will be the URL, or let's just call it URL then. Our update function is going to do nothing in that case, which is fine. Actually, I'm going to split these two cases out. Not safe to have a wildcard in our update function because we may add new message types and forget to implement them. Then we're going to add an onClick this image, html.events.onClick will produce the image selected message with the web format URL. Let's see if that works down here. Oh, with a record, the URL of which is the web format URL. Okay, so if we click these, yeah, you can see down here it shows image selected, the URL. Great. So now that we have that, we want to expose a couple things. I guess we need to expose our view function. We need to expose our model, our initial model, our view function, and our message type, and our update function. So let's hook this up to our main component. So let's import our image search. And now, in our model, we'll keep image search. We'll have image search.model. So our component, since it contains the image search, needs to hold on to the data for it. Then let's see, in our initial model, ups that, we're going to need image search will be image search.init. I'm just going to rename this to be init. Okay, so our model's all right. Now in our view function, let's see the best way to do this in CSS. I like to stick this on the side. HTML.div HTML attributes.style position absolute left is 0. Let's see, this will hopefully stick it on the right side of the screen. And then inside there, we're going to have our image search.view model.image search. And that will fail because we have the wrong type of message. So we're going to need to transform the message type into a message for the parent component. So this will like this, HTML app.map image search message. Goes in parens. We need to define this message type, which will take an image search.message. Now we need to handle that in our update function. So that's the child message, and we're going to pass that along. So I usually use a let in this case. Child model will be new child model. Child commands equals image search.update. We'll pass it the child message and its current model. And then once we get that back, then we can update our model. So image search here is now going to equal new child model. And the commands we can just pass out. Probably not true. We're going to have to map those commands as well. The message type doesn't match. Yeah, we're using command message, but it's giving us command of image search.message. We'll also have to map these for command.map. Yes, there is. Okay. Let's see. So I want to add also top 0px, I guess. Oh, sorry. Right should be 0 and top 0. There we go. Okay, so we've got our search over here. You can click it and get images. And when we choose one, it's producing an image selected message. Now we want to do something with that in the parent component. So in our update function, we want to do extra thing. So image search message. If we get an image search dot image selected with the URL, then we're going to do something different. And I guess what we want to do is replace the image in the first frame. So I'll say model frame is equal replace image. And let's have this take a path. I'm just going to hard code the path for the moment. Then we'll need our replace image function, which takes a frame path and a new URL, a frame, and gives back a frame. So we'll have path, new URL, frame, and depending on what it is, we'll do something different. If this is a single image, then we're going to return a single image of the current image with URL changed to the new URL. And if it's a horizontal split, then I guess we're going to check the path. Okay. For the moment, let's see, just to check if this is working. We'll follow the correct path. But for the moment, let's just return a new horizontal split where the top, we apply the replace image to the top. All right, so it says image search is not in scope. And it should be line 140. Image search. Got image selected. Okay, well, I'm not exporting the message types, so I need to put dots there. And on line 162, this is current.top. Now, third and fourth branches are different. I didn't pass the frame. I'm invoking replace image. Okay, so we can drag around. If we choose an image, it replaces the top one. Cool. I'm actually pretty happy with that. So this whole project is still very much, I feel like, in the debugging state, but I solved all the problems I wanted to solve. We can do the drag and drop. We can drag the sliders around. We can have nested frames and nested splits, and the dragging all works for all of that. So I think I'm going to wrap it up here for today. we have an image selector that at least has the basic functionality. We need to add a search input here. There are some few other problems right now, like we don't correctly get the width of the image when we swap in a new image. So that's something that would have to be dealt with. The UI is a big mess at the moment. We've got all this debugging stuff going on. So, well, I guess I'll put the code up, and anyone that wants to try to solve some of those remaining problems, please do so. I think I'll probably end up working on this project again in the future. This was pretty interesting, I thought, and kind of a fun use of my time. Let's see. Integrate image search with main UI. So yeah, well, I guess that'll be it for today. I'll probably revisit this again in the future and do some more cleanup. And also, I was thinking in JavaScript there's a way that you can render an HTML component to basically get the image data out of it, and then you could produce like a PNG download of the final image, or potentially like upload that to Imager or some other API. I love to work towards doing that at some point as well. So I guess there's a lot in this project that could still be worked on. So again, the gist is up. You can look at the link in the corner of the video. And let's see, what else? Yeah, I would love to hear from who's watching these, and if you've found it interesting or useful. I'd also like, my goal is kind of just to start building a community of I guess Elm, but not just Elm, even like having people working on open source projects and doing more streaming of that, and kind of having a community of more people sharing what they're working on and kind of working through different problems in different languages. So if you have any side projects you've been working on as a result of this, or anything else open source, I would love for you to share the link with me. And I'd also love to hear feedback from where you're at, what you know about Elm already, and just kind of get a sense of who's been interested in this. So with that, I guess I will say goodbye for today. I won't be streaming next weekend. I am going to AndConf, which is a technical conference for intersectional feminists, which I guess briefly I should explain that, because I didn't know what intersectional feminism was before I found out about the conference. But it's basically the idea that like women have been facing discrimination in the tech world, but beyond that, people who are part of members of multiple marginalized groups. So for example, a woman who is also Black and trying to work in the tech industry, or someone who is maybe has a disability and is also a Latino, for example, like people that are part of multiple marginalized groups simultaneously often face very different experiences and different challenges than people who are just a member of one of those groups. So intersectionalism looks at what we can learn and how we can identify and try to address inclusivity and diversity in a more comprehensive way when we kind of look at the experiences of multiple types of people all at once. So I don't know a ton about it yet, but I will hopefully learn a lot from the tech conference and all the people I'll meet there next week. So no streaming for me. Maybe if anyone else is wanting to stream, next week's a good time to try it out and grab some of my viewers. But in any case, I will leave it at that. And have a great weekend.